Thank you. I will give you this kind of a very short overview from biotechnical plastic recycling and then this bioplastics. First, this kind of unfortunate fact that until 2015 there has been over 6,300 million tons of plastic waste generated, and only 9% of that plastic waste has been globally recycled. And majority of this plastic has transferred to landfill or has lost to environment. In Europe, 2020, about 30 million tons of post-consumer plastic were collected, and about 35% of that was recycled, and still 23% of that went to landfill and environment. This 35% is already a very good one, but we have to remember that in EU directives said that 2025, 50% of post-consumer plastic should be recycled. One challenge in plastic recycling is that when we are talking about plastic, it's not only one kind of plastic. So there is different types of plastics. And for example, 2020 in Europe, 20% of this plastic was polypropylene, which were used, for example, in food packaging. And 17% low-density polyethylene was used in plastic bags, and 13% in high-density polyethylene. And one interesting plastic group is polyethylene terephthalate, which was 8% in Europe, which was used in drink bottles. We can say that there is three different kind of methods to recycle plastics. There is mechanical, which is well established, and it's mainly to polypropylene, polyethylene, and PET. The drawback in this mechanical recycling is that the quality of this plastic is decreased during this process. Then there is chemical recycling, for example, gasification or pyrolysis. And there is development work, and the aim is that other plastic than polyvinyl chloride will be recycled. Drawbacks there is that it requires high energy. And what is coming in the future is biotechnical plastic recycling. It's very early stage, but there is examples to recycle PET. When we think this different plastic recycling system, we have to think that they are not competing to each other, but they are complementing to each other. So these collection, sorting, and washing steps are similar to all these different kind of recycling systems, and then they can be mechanical, chemical, or biological recycling. Previously, this biological recycling were mainly so that this kind of end-of-life plastic, that if that was possible to compost, it was composted or then fermented to biogas. But nowadays there is coming more and more this kind of high-tech biotechnology recycling. And what we mean with biotechnical plastic recycling? We mean that there is plastic degrading microbes or enzymes which can degrade this plastic. When we have enzymes, they are mainly producing this kind of monomers, which can be then repolymerized back to this original plastic. Or then in the future, there will be microbes which will use this plastic material as a raw material to produce wanted products. So it's more this kind of upcycling of this plastic. In biotechnical plastics recycling, more challenges is coming from that one, so that chemical structure of these plastics are so different. There is polyethylene, polyvinyl chloride, polypropylene, and polystyrene, which is only this kind of carbon-carbon skeleton, and there is not this kind of active groups that where these enzymes could digest or cleave this plastic. With ester bonds, there is, for example, polyethylene terephthalate and polyurethane, which are much easier to enzymes to degrade. And here's one example. This plastic degradation with enzymes is with PET. So there is enzymes which can degrade this polyethylene terephthalic polymer to terephthalic acid and an ethylene glycol, which can then be repolymerized back to PET. And in this polyethylene terephthalic degrading enzymes, there has been really many studies ongoing where this speed of this degradation has been really increased with artificial intelligence or machine learning systems. And there is also one industrial examples from PET degradation recycling, namely Carbio's company from France, and which is developing enzymatic plastic degrading systems. They have achieved a couple of years ago 97% PET conversion in 16 hours. And they announced 2019 that they have produced first PET bottles from 100% recycled plastic waste using this company's breakthrough technology. And they are also building an industrial unit that which should be ready 2025, when the capacity is to recycle 50,000 tons of PET plastic waste. There is no biotechnological recycling system to other plastic than PET so far. I think that most probably the next one will be these polyurethanes, which are also polyesters, which are easier to enzymes, but these other plastics than polyesters are very difficult to enzymes. And there is no good examples from this kind of enzymes so far that identified. At VTT, we have discovered some good enzyme candidates which can degrade to some level this polyethylene and polypropylene, and this developing of these enzymes is ongoing. With these enzymes, and like the others who is studying these plastic degrading enzymes, has seen that plastic is not easy material to enzymes. They are very hydrophobic, and then their crystal structure might be very difficult. And for that reason, we have ongoing project that we are, with our chemist, chemically pre-treating this plastic material so that it's more hydrophilic and more acceptable to these enzymes to degrade to smaller units, which will be then carbon source to biotechnical conversion to produce specific products. Because we can think that when we have this plastic and we have specific enzymes which degrade at smaller units, and microbes are utilizing that one. If we are not modifying these metabolic pathways, they are most likely going to CO2 and biomass. But in the future, I think that there is very good possibilities to, with synthetic biology, modify these microbes so that they are producing wanted products from this plastic raw material. So then we are upcycling this plastic waste. One group of plastics are these kind of bioplastics, which are polymers generated from renewable biomass sources, and they are not petroleum-based. They are directly from natural biopolymers like polysaccharides or proteins, or they are produced chemically from sugar derivatives or lipids, or they are fermented with microbes from sugars or lipids. Unfortunately, today, amount of bioplastic is only 1% of total amount of plastics, what is around us. And one thing what we have to remember when we are talking about bioplastic is that not all bioplastic is biodegradable. For example, biopolyethylene and biopolypropylene, which are made from natural sources, the structure is similar than petroleum-based plastics, and they are not biodegradable. But luckily there is examples like polylactates and polyhydroxyalkanoids, which are also biodegradable bioplastics. A couple of 2021 about these bioplastics, we can see that almost half of that has been really this non-biodegradable, like polyethylene and polypropylene, which is well-known plastics. But unfortunately, there is also this kind of biodegradable bioplastic like PPAT, PPS, PLA, and starch blends and cellulose-based material. One interesting group of this kind of biodegradable bioplastic is polyhydroxyalkanoids. They are naturally produced by bacteria to store carbon and energy, and these polyhydroxyalkanoids are generated from different length monomers, and there is over 150 different kind of monomers which has been identified. And with these different kind of monomers, depending on length of these monomers, the properties of this plastic might change. So in that sense, there is very good possibility to make different kind of plastics with PHA. The simplest polyhydroxyalkanoids is polyhydroxybutyrate, and that, for example, that characteristics are similar to polypropylene, and there is also industrial scale production in Asia. And in addition to this natural producing bacteria, there is really several projects ongoing to develop other microbes which can produce these polyhydroxyalkanoids, and also copolymers, where is polyhydroxyalkanoids and, for example, PLA. Here is one example so that really in these bacteria they are doing inside the cells these kind of polyhydroxyalkanoids which can really use in different purposes. And one interesting thing in polyhydroxyalkanoids is that it's also biodegradable in water. And if thinking the bioplastic in the future, so 2021 there was 2.4 million tons of production, and it will increase to 7.6 million tons in 2026. And so there is increase, and I hope that this increase will be also higher than in the future. There is challenges in bioplastic because there is there is already very saturated markets in the related to plastic. So the properties of this plastic should be the same or better than petroleum-based plastics. And also what we have to think that this bioplastic recycling should be also established. So far, if thinking that there is only going to biocomposting and so on, so then we don't have this kind of closed loop in these ones. But now when this bioplastic development is the early stage, so I think it's good also think this kind of closed loop thinking, so that it's also we use this material again to produce other plastics. So thank you.